All right, we can get started for Weather Watch for February 16th. This is a look at the week-long infrared loop. I'll let this restart. But there are several things that happened over this past week that are interesting you can point out here. First, I'll draw your attention to Canada once this restarts here. So you can see all of this like non-moving blue, almost yellow-green color is all the cold air. And throughout this entire week, we don't see any of it get into the United States. You'll see it begin to start appearing south of Hudson Bay, then it comes around the west side, here's all the cold air, but remains well north of the continental United States, and that's been apparent. We've been pretty warm for a while. Looks like we'll continue to be warm as this cold air is just sitting to our north and not making it anywhere south into the United States, aside from at the very end of this loop, you'll see it kind of get into northern Montana, North Dakota, where they were below zero this morning. But aside from that, it remains all the way trapped in Canada here. You can kind of see it as the nighttime progresses, it gets larger, cooling, and then with the daytime heating, it disappears. The second thing I want to point out, on the periphery of this jet stream, right here, there was a snowstorm that happened in the panhandle of Texas and into Oklahoma. Upwards of 8 to 12 inches of snow fell, in Oklahoma and portions of Texas, and you can kind of see it. I'll wait till it re-loops here. But that was a significant snowstorm for that region. My uncle lives in Lawton, Oklahoma, which is like right there about, and they were in this rain-snow mix of heavy wet snow. So you'll see it begin to develop right here. Here's your snow and rain and mix in winter. Then as this moves away, can we pause it like right there, please, Pete? Forgot we can do that. Once it's daytime after this, right there, perfect. This is all snow cover, all those white colors right there, that's the snow cover, and you can see if you want to just drag it ever so slowly throughout the day, you can see it melts because, southern plains, it gets to 50, 60 right after any of these events happen, and if we go to the next day, you'll even see it. Let's see here. You can see it's kind of almost completely gone, and here's that bullseye where my uncle lives. Just to the north, they got 8 to 12 inches of snow.
I see the flag is...
Right, exactly. And then we can keep playing it here. So once this restarts, that same snowstorm that occurred in the southern plains here, so you'll see it again begin to develop on the periphery of this jet. Here's your snowstorm. Here's a jet stream that's not moving. Once these two collocate, you'll see with right towards the end, here becomes a significant snowstorm for the northeast. I know parts of Connecticut got about 15 to 16 inches of snow. And this, could you scroll back just to the start of this event here? So let's see, it's like 4 UTC, whatever, on February 13th. If we go forward, please, we can just let it play. Good. So here it begins to snow. Let's say 10 UTC. I'm just watching the clock here. And it's snowing, it's snowing, it's snowing. Probably about 10 hours later, you get 15 or 16 inches of snow. Yeah. That's very heavy snowfall, very heavy wet snow for most of the Northeast. You can see it on the visible loop of this band of very heavy snow. And it was a band from like West Virginia straight through Connecticut and into Massachusetts. Same snowstorm that happened over Oklahoma and Texas. And then if we press play, you'll see that this same system becomes a gigantic system over the Atlantic, 948 central pressure, so very impactful. Portions of Newfoundland got up to 36 inches of snow from that same event that started over the west. And I hate to point out, but that missed us completely.
No, you don't hate to point it out.
Well, I do. I like snow. But you'll see here, here's our little snow event we had Wednesday into Thursday right here. Pretty heavy convection. I know there was a mesoscale discussion of 1 to 2 inch snowfall rates for us. we got about 3 inches total at the airport, and you can see that
Yeah.
blow up of
Right
convection right over us. Unfortunately, it lasted for about maybe like 3 to 4 hours, and then it was well off past our region. But it's now bringing snowfall in its wake, lake effect snow in the Great Lakes, which are completely ice-free. And I believe that's a historical low. They've never been completely ice-free ever. So a lot's happening, as evident by this. And then if we could stop it at the very last image. Here's your jet stream that is still sitting almost in the exact same places where it started. So this has been a persistent feature for a week and a half now, which is interesting, and it's creating a lot of weather over the eastern United States. It's too far removed from our region to really impact us, but those have been the main features over the week. You can see it, at the beginning. It shifts maybe 200 miles south throughout the entire loop. I was trying to look up the observations for Mexico. I do not know a good website for that. You can't find it online, but I wanted to know how much rain fell. It seems like there's a persistent moisture stream throughout at least a week, and it blows up through portions of this loop, but I don't know. Maybe there was a lot of rain. Maybe there
So I'll
wasn't.
add, my parents right now are in McAllen and Brownsville, Texas, which is like the very tip of
Oh,
the
yeah.
island. And they currently are forecast to have 3 to 5 inches from this last little bit,
Okay.
which is extremely not common. February is rainy, but not that rainy. But what's one of the big things there is that you get a lot of rain in February and March. And this is like prime growing season. By the time you get to the dry season, that's fuel for potential fire weather. So
Absolutely.
that's like a consideration.
And I'm sure, moisture from the southwest is probably weird
Yeah.
versus the southeast where you have the Gulf of Mexico is probably an interesting thing happening there too.
It puts the kibosh on the elevated mixed layer, though.
Yeah.
I mean, if this were to happen in March and April, that'd be pretty good for the southeast
Yeah, it
U.S.
would.
There wouldn't be as much severe weather, I would guess.
It would. So yeah, we'll see if this thing moves. I'm not sure if it's expected to move, but it's been pretty persistent for a while here. And if we could go to the just current North Pacific loop, please.
Did reload this, so this should be good.
Okay. Can we get just the one of right now?
Oh,
Yeah. For the only reason that I didn't look at this, you'll notice if we could could you start like just maybe 12 hours before and just slowly loop forward. There we go. Okay, that's perfect. So you'll notice there's a gigantic feature, a gigantic ridge sitting over the western North American continent into Alaska. And if you just let this slowly play out, you'll see all of this assumably moisture from the tropics is getting pumped up well around this ridge. And underneath it, it looks to be a lack of cold air. As evident by, you can see kind of the peaks of the mountains where they're snow covered. They're not moving if this were to be looping, but you would expect February there to be a lot of snow covered cold air. This is Canada. There's not. And all the way up into Alaska. So this is something that's interesting. The impacts of this ridge on our weather potentially going forward will be something to look at for sure, because it's so far extended from, I believe, is this 20 north?
41. Or 30, sorry.
30?
Hawaii's at
Yeah,
23
those
and a
are-
half.
Okay, so 30 north all the way up to 70 or 80 north is one big ridge feature, and it's just been sitting there for a day now. And underneath it, you don't have any snow covers. You're not building any cold air underneath it, so that might be a sign of things to come for us going forward here, due to this ridge and sort of holding on over itself, as evident by the flow of all these moisture and cloud features in the infrared loop here.
Yeah, my eye is drawn to this pinwheel thing in the cold air that's kind of developing.
This-
No, further to
Oh,
the southwest. That
yeah,
thing, yeah.
yeah.
It's an interesting complex. It can't seem to put itself together, but it's got a lot of tendrils, a lot of elements to it, but they don't really turn into a cyclone yet.
That's right, yeah.
Which is cool.
Assumably cold air from the Aleutian.
Yeah,
all the way
very
close to
desperately
Hawaii,
cold,
yeah.
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 Maybe it's so cold, it's just hard to organize. I don't
Could
know.
be.
Those are big convective elements.
Yeah, you can see it swirling. And then something on its, right on its tail looks to be pretty impactful. And then if we could go to our super peaks now, please. We're gonna look at the upper air, current upper air conditions, and I'll start with the 500 hectopascal super peak, please. So we're gonna look at the troughs and ridges, and one gigantic feature you can notice again at 500 millibars is this ridge that extends, most of western North America, and on its up downstream side, we get this northerly flow and a confluence pattern of the winds over the entire eastern United States. Weak, but it still is confluent, where you have this southwesterly flow, slightly southwesterly, over the southern United States, and then straight northerly over Canada. Here is the snowstorm that impacted us on Thursday morning, Wednesday evening, tied to the shortwave. Here's that system that impacted the southern United States and then into the northeast, sitting off the coast of Canada. What else do I want to point out? Oh, and then one thing to notice too is the temperatures at 500 millibars. So underneath this ridge, temperatures around -20, all the way up into Alaska and close to the Arctic Circle. And then the same temperatures you can find in Oklahoma and Texas. So that's how anomalously warm for this level and this time of year this feature is, where you can find the same temperatures, in the southern United States here. And we're sort of in this zone of maybe there's cold air advection from North Dakota into Minnesota. We're kind of in this no man's land of there's just general weak confluence over our region. So not any real trough or ridge feature to be discerned at this level, at least. And could we go to 300, please? So we'll get a look at the jet stream. So you can see it's kind of a mess right now over the eastern United States. We'll take a look at what kind of jet streams these are, polar or subtropical. You can notice here's the jet, or the ridge, still prevalent at 300 millibars, and assumably a polar jet on its northern edge. Here's your cold air, as evident in the infrared loop where we had our coldest temperatures. We're just south of Hudson Bay, but that's really the only region you'll find cold air based on this map. There's a lot of warm air over Western Canada, and then it's just confined to our north. We're sort of in this, it's about average for this time of year, not anything too cold or warm for this area here. And then here's the gigantic storm that is, even at 300 millibars, is pretty widespread, and it's disrupting the flow, I should say, at 300 millibars as well. So if we could go to 250, we'll take a look at these two jet features, and we'll see the feature. There was a jet streak over Michigan that weakened as we went higher up, so that would be a polar jet stream. And then there was a feature over into Oklahoma, Kentucky, and then the Virginias that strengthened, so that would be our subtropical jet. And these two seem to be interacting. They're not currently, but we can look at a cross-section of them in a moment here, and you'll see they're kind of beginning to superimpose, which means they're becoming vertically stacked. When that happens, there have been multiple studies I know of that the mid-Atlantic states get some impactful weather, and there are actually some winter weather advisories out for this part of the country. So I'm not sure if they're exactly related, but you could expect that the superposition of these jets to have some impact on the weather over the mid-Atlantic. And then further, you can see the strengthening of the subtropical jet down into Mexico and Texas. So here's your main subtropical jet that has not really moved for the past couple of week or 10 days, and beginning to become one jet as you go higher up in the atmosphere. And we'll see that if we go to 200 now, please. We'll see that become even more apparent. as here's your
206.
206, yeah, knots.
Wow.
So this is a very strong jet streak, and now it's clear that it's one jet feature and not two. And then you can see that this feature on the periphery of this ridge has weakened as we go higher up. So this is definitely a polar jet, and would make sense. It's way up into Alaska and Canada, and it's February. And then there's another feature off the coast of the United States and Mexico that might bring some impact weather. I haven't looked at the forecast at all, so that will be something to watch as well. You can see it encroaching on us as we go forward. And then if we could do a cross-section
Were
through
we
this
talking
jet.
about a really strong jet, kind of in that same region, still south of there last week?
Yeah,
We were talking
yeah.
about like FedEx.
Oh, that's right.
It's a repeat.
It's a little
I mean,
north
it's
south.
amazing. And we
Yeah.
had something slight, I don't think it was over 200. This might be the first over 200 of the year, but it was close. It was 190 something.
Yeah.
I'd like to know the climate of that. I have a feeling there's been a
Yeah.
trend.
Yeah.
Man, this has been a really wavy winter.
Yeah.
And there's something about that that leads to this that's intriguing to me.
Could we go to
Go to
tropical?
tropical?
Yeah.
Oh, yeah, that'll be nice.
And I'll cut a cross-section through this. And I just did the GFS. If we could go to upper dynamics and 250 wind, and that from north of, yeah, that's perfect.
This is
straight
Dallas
south.
18. I wonder if the 12Z looks different.
Oh yeah, we could check that, I think. Then could we do PV on this cross-section? Okay, let's, if we go back.
Boy, it is.
We'll just drop a little to the west, maybe from north of Wisconsin straight south. I know I got a good look at this earlier here. Perfect, this works. So what you're seeing here, A is the northern part, so this is in Canada, and then this is in the Gulf of Mexico. What you can see, we have our first jet streak and our second jet streak. And you can see how they're vertically, they're not the same vertical level. One's around 400, maybe 350. The other one's around 200. And so this is your polar jet, closer to the surface, lower thicknesses below it, and then higher thicknesses below your subtropical jet. It's higher up in the atmosphere. And so this is a classic two-step jet streak where jet stream where you have a polar jet and a subtropical jet. And we'll see here if I could, if we could X out of this.
Where did this come from? Is this left over from connected to this, or?
I don't
Maybe
know.
you can't
what
tell
it
this
is.
by
Yeah,
cross-section.
Little surface front.
Yeah.
could be.
That's where it's probably snowing today, right, in Illinois?
Yeah.
Oh, could be, yeah.
Probably what it is.
And if we could just go a couple hours in the future, just see, once this is one more, perfect, and then cut a cross-section straight south and do that as well.
Yes, perpendicular to the aspects. Great.
And you can see now going forward becomes one gigantic feature. You lose that step in the PV, and then you have your maximum winds at one level rather than two, and you can see this is some upper front feature. And I don't know the implications of this, the weather in the southeast. If this is impacting the snowfall, it most likely is, but I didn't look into it. So this is something to look out for going forward. Just one day of what does this jet superposition mean for the weather of the southeast.
They often lead to an increase when they get kind of close to vertically superposed. They lead to an increase in the horizontal speed of the jet.
Yeah.
That's notable, and it looks like that's true here. And then
Absolutely, yeah.
naturally, then the secondary circulations at the entrance and exit regions will be enhanced.
Right.
Because the accelerations are greater. And I think that's probably going to have an impact down over Alabama, Mississippi, and Georgia today. And this is today, right? Yeah, today. Or tonight. Thinking about maybe some thunderstorm activity. I don't know if it's severe or not. But.
Right. And I do know there's an expected decent amount of precipitation for the southeast, at least one day going forward. So that is all I had. Is there anything else anyone wants to see or look at? Okay.
I guess, can you do cross sections in like over Alaska? Is that a possible thing to do?
I believe you
I'm just
can.
really curious about the ridge.
Yeah.
I don't know if,
Let's
I've
see.
never tried to do cross sections here in Alaska.
You're
Can't
too,
really get the
it's
whole
hyper
ridge.
focused on Alaska. That's the
Yeah.
unfortunate.
Okay, well, that's fine, we don't need
Pacific?
Oh, yeah.
Sometimes you
Or
can't do
northern.
cross sections. Let's try it. Let's try the North Pacific first.
Yeah.
Okay, this might work.
How do you want the cross
Maybe
section?
like east or west to east,
Like
like
across
through the
here?
ridge.
Maybe from the region where it says low pressure. That's where I'd go.
Too far.
From the L up to the archipelago, between the two lows, from
Yeah, yeah.
1,003 to 976. Then you're kind of cutting right through the.
PV?
Sure.
You know, thinking went far.
Yeah, I was just looking, the temperature from 500 to 200 didn't really change. Oh, yeah, it's really, okay.
We can help.
Not as exciting as it was.
What is interesting, though, is how poorly stratified the middle troposphere is.
Yeah.
Right.
And then suddenly, right on the ground, you have all your stratification
Yeah.
because of the subsidence. I mean,
Yeah.
there's this historic subsidence, and it's a heat sink as a result.
Yeah, looking at the superpeaks, the temperature change in the middle of the ridge between 500 and 200 was about 40 degrees.
Oh
And
my
then
God,
over
yeah.
Canada, sort of Hudson Bay, there was no change. So just looking at that.
Yeah, the big bubble of warm air, that's gigantic.
But it
And-
answers your question, you can do cross sections.
Yeah,
Yeah.
that's good to know. I'll play around with that more.
All right, thanks, Patrick. Pete, can we go to Alicia Bentley's maps? No, don't do that. Tropical's good. Let's stay on tropical, but let's change the region. Let's go to the North Atlantic if we can do that. Yeah, they call that the tropics. Okay, and I'd like to see the sea level pressure.
You probably know.
Yeah, that's okay. I thought there was one with Greece on it too. There isn't?
It could be.
Oh, yeah, that's what I want. Yeah, okay, great. And let's go back a couple of times to a different run then, because I want to see yesterday's. Let's have this initialized at 0Z on the 14th, right there. And then let's slide back to the beginning time. Because this is the storm Patrick's talking about. This is a really interesting storm. Click a couple more times, we'll get to the lowest sea level pressure. 956, 952, 951. That's good enough. Let's go back a couple. Right there, 952. So this is the same thing that gave us, or that gave New England its little snow on Tuesday, some places a big snow, and gave us a little brush earlier in the week. And it took forever to turn into this really deep cyclone, 952, and it's got a beautiful occluded structure as well, which I think we can interrogate with a cross-section. Why don't we do that? Let's do one right along there. Great. And let's do theta E, yeah, that's gonna work. First, and then we'll do another variable in a minute. Okay, cross-sections, that's because they're tropical. But anyway, here's theta E, and you can see the plume of extreme vertical motion. Here's the warm frontal portion of it, closer to B, right? It's up in this region. And so 315, I think, Kelvin theta E comes almost all the way down to the ground. So there's the cold frontal portion of the occluded structure and the warm frontal portion of it. You can even see it in the isotherms, which is nice. But the bulge right in the middle. And then there's the strong horizontal frontogenesis in the lower troposphere, which is probably accounting for some of this vertical motion, but certainly not all of it. And that is, it's too deep to really ascribe just to that. Even though stratifications, we kind of know there's other forcing going on to help in the middle and upper troposphere as well. This is a lot of vertical motion, and it's characteristic of that portion of the storm. Let's take a look at the PV on that section. I'll imagine there'll be a kind of a local minimum at the tropopause in roughly the same spot. It looks like that's it right there. So that's a local bulge in the tropopause upward, and then here's this is really interesting, it's kind of a PV tendril down along the warm front in this case. Wow, how do you like that? And then there's something back here from the cold front. So that's the occluded sector right in there, and theta E, or it's a theta, I guess it's theta, yeah. Theta is pushed downward where it's warm, and then you can see a little bit of an upward protrusion toward the cold air, and then an upward one in the warm front. So where you have the local maximum in theta in the lower troposphere is right where the trowel resides, right in there. So it's a pretty nice event. What I'm doing for fun with this thing, if we can just take this off, I just want to say one thing about it, is I've been thinking about this problem for a very, very long time. And I came in and busted in on my office mates yesterday about this. I really want to know what's the relationship between the vertical motion and the production of vorticity and cyclogenesis at the low levels. And you say, what? People don't understand that? And I don't care who's in the room, I'll say, no, we don't understand that. We really don't get it. It's not as clear cut as you'd think. So what I'm trying to do now is I take my QG omega, And this is all inspired by Sutcliffe 1939, where you look at two different levels in a column and you figure out the difference in the divergence. What if one of those levels is where there's no divergence? And that's the level of non-divergence, which should correspond with the maximum vertical motion. Because as soon as you get past that, you got to have upper level convergence to start working back down on your vertical motion. So search every column for the location in pressure space where the maximum upward vertical motion comes in, and then subtract from that 1,000 millibars. That'll give you minus dp, and then the difference in omega. There's no omega at the ground, and whatever your omega is there. It gives you an aggregate of the column stretching beneath the layer of non-divergence, and you can plot that. And I don't have anything ready for you yet today, but what I intend to do is look at where the cyclone center is, and at this time, I can tell you because I've looked at it, at this time, there's a big patch of general, from the QG omega, big region of upper divergence here, and an even stronger region of low-level divergence right here. So what I hope to do is take a look at how does that spatial relationship between where the cyclone is and where the maximum low-level convergence is from the omega. So it's based on knowing what the omega distribution is. How does it relate to the position of the cyclone? Does it ever overlap with the cyclone? And then, if that works, you can start splitting up the omega into all these various pieces. What's the part forced by shear vorticity advection by the thermal wind, curvature vorticity advection by the thermal wind, frontogenetic activity? All of it can be separately done. You could split the forcing into upper and lower troposphere and look at the same thing. So we could have a partition fest on this thing. It's really in honor of Dan Kaiser, and really start to see some interesting things. Not only that, you could do a composite. You could say for every cyclone below 980 millibars, draw a box 20 degrees by 20 degrees, and do a composite of all of these signals relative to the intensity of the storm and in its life cycle, and really find this out. Are there different kinds of storms? And are there different kinds of dynamics that seem to be driving certain different types of storms, and then back away from that and say, let's look at a case study of all of these different types and see how different they really are. So I've got this whole thing mapped out. I just need somebody who wants to work on it and somebody who wants to fund it. That's hotter. So anyway, this is a great example. I'm going to keep on hammering away on this storm because it's such a pretty storm, and I think it might be a good place to build some of the infrastructure needed to do this project. So that's what I wanted to show on that. The other thing I want to show is this is new news to which you will all be privy once we get to this thing. Are we on there? Okay. This is the time series for the 850 millibar cold pool for this winter up till yesterday, February 15th. And this is the second warmest winter up to that point in the 77-year time series. So what I did is, let's do one other thing. I looked at the warmest year ever, 2014-15. That's what it looked like. An incredibly warm December, a really incredibly warm mid-January, and then another incredibly warm period in mid-February. Very different tale of the tape up to this date, 15. So I took the last 11 days or so from this time series and put it on this one, just to see what the target is. Number 2 and number 1 are fairly close together, but number 3 and 4 are way below number 2 and 3, 1 and 2. So we are in the same realm. If we can do better than this, so consistently lower than that across the month, we might be the all-time warmest winter in the NSEP reanalysis time series. So that's the mark. How are we going to do? We have to avoid a cold outbreak around the hemisphere that gets us to 1 standard deviation below the daily average here on the 20th or so. That's Libby's birthday, by the way. So we'd love to have it happen there, really crush the record right around the 20th of February, so that would be extra special for all of us. But that's the mark. If we mimic this, we don't win. If we're below it more often than we're above it, it'll be an interesting discussion next Friday. So that's what's coming this week. And this was just our one cold outbreak of the year, and it coincided, as I've told you a couple of times, with a decrease in the hemispheric aerial extent. So even though that was a big bowl-shaped cold air outbreak over North America. So getting cold next weekend, which will be in the forecast, over North America, doesn't make me nervous because the same thing happened here and we went down. So I'm not concerned that that will be a deal breaker. But a totally different complexion to this winter that is in the running to be just as warm as 2014-15. To me, that's really interesting. Okay, now let's take a look at what we might expect locally, at least, over some of the period that we're looking at there. So Pete, if we can go to, let's go to your maps instead of these on the website. And let's start at 12 hours at 500 millibars. So that'll be tonight, I think, if it's the most recent one. Yeah, this will be tonight. And so we see a couple of features that Patrick mentioned so nicely in his discussion. The Big Ridge. This is a huge area of real estate where you mentioned a couple of things about it. No snow on the ground, not evident anyway, not any really serious snow, and no cold air. That's a big chunk of real estate to make warmer than -5 at 850. And if it persists for this week, which it will for some of the week, that's a huge chunk that you got to make up somewhere else, and I don't know where that's going to be made up. So that's good for us if we want to set the record. So that Big Ridge, and down upstream of it is this kind of complicated trough. This is the feature that has that really interesting pinwheel structure in the convection that we saw on the satellite. And you can even, almost like these vortex streamers look like streamlines for the wind off the high latitudes across the Bering Sea. It's really a big cold air outbreak that's in there, and that's driving that cyclogenesis. And then the broad feature we saw in the clouds has really not got a center of cyclogenesis as much as this one does, but that's broadly related to that. And then back over here in Greenland, this is a dilapidated now Valentine's Day storm, some 3 days downstream from it. The one I was just talking about was in better shape then. But this one's taking shape just south of Newfoundland, so they're still digging out of the 3 feet of snow that this one deposited on them. I suspect they're going to see a little bit more by the time they're done with this one. So it's been a really, really stormy North Atlantic over the last couple of weeks. And I would say my sense is, and I do have a measure of this, but I didn't dig it up to bring it. My sense has been that this winter has been unusually wavy in at least this part of the Western Hemisphere. I don't know if that's actually true, but it wouldn't be hard to verify that because I'm calculating 300 millibar waviness every day. I just don't look at it often because I'm more interested in breaking the warm pool record. So I just can't, I'm distracted by too many things already, so I can't do that too. But it's there for looking at when the weather is warmer and nobody can. So let's go a day ahead, Pete, and we'll watch some of the features. I have a feeling that we're going to have a relatively boring week in terms of feature progression across the country. The ridge opens up a little bit, I'd say, at its lower latitude mouth, so that it encompasses a fairly 2/3 of the United States. Strong northwesterly flow just to our north almost surely means it gets chillier, and I think you'll see that at 850. We can't help it. We're going to be chillier over the weekend, and then the progression of this complex of small shortwave features within the broad long-wave trough is going to complicate the middle part of the week, and then we'll talk a little bit about the end of next week, which looks a little less complicated and a little bit colder. So that's kind of the broad picture. But with strong northerly flow all the way from the north slope of Alaska down to southern Illinois, Carbondale area, that means it's going to be cold in the central United States, at least the northern Great Lakes states. And so let's go to 850 here at 36 hours. I think we'll get a picture of what I mean. So here's the really deeply cold air, and especially cold over Baffin Island. And but this is in the -24 to -28 range. It gets to the -30s there at 850. And on the cyclonic shear side of that strip of northerly flow, you get a little bit of a clipper-type system putting itself together on the southwest shore of Hudson Bay. And it even ingests the baroclinicity to an extent. There's a bit of a warm front, the thermal ridge, and the cold front. And then cold air advection really in earnest back here over northern Saskatchewan. And we're fairly chilly. We're in the -8 range here by the time we wake up on Sunday morning, or getting ready to go to bed anyway, Saturday night. And probably a little bit colder by Sunday morning. But the desperately cold air seems poised to move off to our north and east as opposed to right over us. So let's go a day ahead at 500 millibars. So we'll go to Sunday night. And one sees a continued northerly flow, although it becomes a little bit more westerly so that it ends up, or originating over the north slope, flow ends up over southern New England as opposed to southern Illinois, which I think guarantees that cold air is kind of shunted off to the east. But nonetheless, still some northerly component to the flow, even at 500 millibars, though more broadly weak westerly flow. And then this feature here is conglomerating a little bit off the coast of the Pacific Northwest. Perhaps this high-resolution vortex structure doesn't really tell the picture of what that thing might look like from a diagnosable perspective, you might be able to see that this is all one giant chunk of what this means, so one might expect a fairly nicely organized cyclone off the coast by that time. Let's take a look at 850 at this time. So there's our really cold pool of air. It's limited aerial extent. It's made some headway southward towards the border with Canada, but only to our east, longitudes to the east. There's very weak, if any, cold advection, and just to our southwest, a little bit of warm advection. So this is by Sunday night. I think the worst of the cold snap for the weekend is over. Notice that underneath that 500 millibar feature off the west coast is a pretty decent 850 millibar geopotential height minimum, but all the barochronicity is well to the south. So this thing is, kind of deeply divorced from the peak of the warm sector. It probably doesn't have much developmental potential, but it probably still has a lot of sensible weather potential. In fact, I'd like to see what the surface forecast is at that time. Yeah, down where it intercepts the barochronicity is a little bit more intense. Precipitation south of San Francisco Bay, a little bit on the north coast, but not a really well-developed precipitation shield, apparently, with that cycle. So that's too bad. But here, in a different depiction, 1,500 thickness, one can really see the intense barochronicity that's just on our doorstep, and boy, it's going to struggle to get here. One of the things that you can say from a picture like this is that all of the disturbances in the strong vertical shear flow tend to move in the direction of that flow, and so this anticyclone is likely to come to about here, north of Minnesota by the next day or so, and this cyclone moves off again to Newfoundland. They're just getting out of the way of this one by Sunday night, and this one will come in and give them a little dusting on top, just to remind them who's in charge. And so we'll probably see this anticyclone sag to the south and east over the next couple of times. Let's go to maybe 72 hours at 500 millibars first. So broadly, a fairly deep long wave trough is being cut off over being carved out over the eastern 2/3 of Canada, south of the archipelago. There's the leading wave that was the second of the big storms in Newfoundland. Here's the one that's giving them their last dusting, and then there's a feature off to the west over the northwest part of Hudson Bay. Landfalling of this dilapidated structure, though still fairly interesting looking structure on the west coast, and then increasingly westerly, even slightly southwesterly flow in the mid part of our own state at 500 millibars. But not really strong flow over the terrain at this point. Right about there is where the Rockies are, and that's exactly where the flow reaches its minimum right now at 500 millibars. So one doesn't expect any substantial warming immediately in the lead by Monday. Let's see if 850 verifies any of that. Yeah, not particularly, there's no obvious warm bubble, maybe a little bit of a hint of one over Texas, but not really anywhere else. And there's a weak cyclone that's kind of just to our west. The chilly air has been more or less stationary, amazingly, and moved a little bit further south than it was at the beginning of this description. And then the cyclone is just kind of spinning off the coast of Northern California, presumably showery activity over much of the coast of the state, maybe even a little bit inland, but nothing more than that. And then a lot more barochronicity up over the Bering Sea. Okay, so and we have at 850 by the time we get to Monday morning, pretty obvious warm advection. And that'll get us towards about 0 degrees at 850 perhaps by the end of the day. And that's not so bad. Let's see what the surface looks like at this time, just to see the progression of those features. Yeah, the anticyclone's kind of slid to the southeast as was rather generally expected, and then the cyclone weakened a little bit but moved off to the northeast as well. And here's a weak little cyclone that's developed, and we saw its reflection at 850 over southeastern South Dakota. And that's circulation around that is also contributing to the warm advection. Though it's limited at our latitudes, it's a little bit more intense further to the south. But a little bit of warm advection, I think, provides us security against the invasion of that really cold air more than anything else. I don't think I consider that a substantial warm-up. Let's go a day ahead, Pete, to 96 hours at 500. So there goes our little disturbance that was responsible for the weak circulation to our southwest on Monday at 12Z. This is a day later. Big ridge over the mountains. I suspect that means now we probably have some lee side warming at latitudes in our vicinity, maybe even some further to the south. And then the deep cold air is staying to the north. That's pretty obvious in this particular episode. That is not going to make any more southward progress, I don't think. Let's see what 850 says at this time. Yeah, the cold air has slid southward into northwestern portions of Hudson Bay. Minus 33 at 8:50 is really cold. But it's nowhere near us, and it doesn't seem like it has any plans to make a southward excursion. And we don't any longer, a day later, have any warm advection, but not really any particularly strong cold advection either. So maybe Tuesday, during the day, Monday into Tuesday is about as warm as we see in the middle of the week, and then just kind of stays put perhaps for the next couple of days. One begins to see a little bit of the lee side warming right there in response to the flow over the high terrain. And so that sets us up, when this gets a little more robust, it sets us up for an episode of warm advection that's really caused by this lee side warming to our west. That might give us something in the middle of the week. I think we'll go two more times. One of them will be proximate. Let's do 24 hours from here, and then we'll jump a little bit further ahead than that to get into the weekend. Strong westerly flow at 500 millibars, pretty much across the whole Rocky Mountain chain. I'm expecting that warm bubble to really look more impressive at 8:50 than it did even at the prior time. And then this vortex strip ensures that the cold air is going to be locked up over the archipelago in the high latitudes of the eastern provinces. We don't have to worry about that. This will be offshore, whatever develops out of this. And then there's going to be something that'll put itself together in response to the presence of this wave, maybe over the Four Corners area, which will probably add to the warm advection potential for the central states, not so much us this far north. Let's see what it says at 8:50. So here's a cyclone off the coast that's got some nice structure to it, so nothing to sneeze at, but it's just it's over Bermuda, and it's going to make its way into the North Atlantic, not going to have a big impact on much of the coast anyway. But here's the warm bubble associated with the lee side warming. You can even see a geopotential height trough there, which is, again, when it's coincident thermal ridge with the trough axis, that's a sign of lee side warming. And look what the response is downstream. How can it be otherwise? Warm advection over Iowa, Missouri, even into southern Wisconsin. So we start to warm up during the day Wednesday. Thank you, Rocky Mountains, because that's what's going to make it a little bit warmer on Wednesday. And then let's go to the weekend, Friday maybe, Pete, 2 days ahead, which is a little more interesting. Yeah, so, well, we can't really do it right here. We're going to do one day before this, because I don't know where this came from. So we really want to know that too. I know that it was coming, but I forget where it comes from. Okay. So here's a little bit of a wave at the backside of what was this broad trough, which, look at that strip of vorticity. I mean, that is telling you cold air to the north, warmer to the south. No doubt. But there's a little wave on the southern end of that thing that has somehow wrapped itself up. That's a question of interest all by itself. But watch what it does. It comes sliding southward stealthily for a while in the northwesterly flow. So let's go to that next one, Pete, the next day. By the time we are at a week from today, this wave is just upstream of us, because there's us, and there's this decent wave. It looks better developed. It's clearly divorced from what was going on there. Very sharp curvature maxima, and that indicates the strong vorticity, and strong shear, I should say, as well, because the geopotential height gradient over North Dakota is really intense. So this is a very sharp upper vortex feature, and let's see what it looks like at 8:50. I'm guessing there's some disturbance over the Upper Peninsula. Maybe it's a little further north than that, but back on the back side, so there's the geopotential height feature, a little north of Lake Superior. But on the western side, extraordinarily strong winds, because the geopotential height gradient's large. That is directly across the isotherms. Strong cold advection Friday morning. And so if you're in the Dakotas, you're reminded that it's still February, very early in the day Friday. I think we get reminded later in the day on Friday. So let's see what 8:50 does at 12 hours from there, if we can. That's a whole day. Let's go only 12 hours. So this is now 6 p.m. or so on Friday, just as we're sitting down to our solstice dinner. And it's very chilly. Mississippi River cold advection across the whole region. Very strong cold advection for us. Our temperature's gone down 8 or 9 or 10 degrees Celsius at 8:50 in the course of the day. And then one more time, Pete, we'll go to the last time in the forecast, available time. And that cold bubble has been modified somewhat, but it's still chilly. And there's the geopotential height trough and a thermal ridge right in there. Makes me want to see those surface maps for the last two 12-hour periods. So let's take a look at those. Let's look at 0Z Saturday. There's our cyclone at the surface. It's not very strong. It's only 1,000 millibars or so, but it's got an incredibly strong thickness gradient with it. air of 504, I think, thickness is this contour right here. That's as cold as we've seen probably all winter, except maybe that January thing we got below 500. And then that's on its way, strong cold advection, bringing it right over us. We've had a little bit of snow by then, but not too much. And then there's the 510 that's gone right over us and past us, so that air is modified substantially, even in 12 hours. But it's going to be a chilly Friday night and early Saturday morning next week if this verifies. And this is a fairly small scale feature. The last wave on a train that had imprisoned the cold air to the north over the whole week, while we kind of go through mild fluctuations until this thing finally breaks at the end. And we get pretty chilly on Friday and Saturday next week. So that's what I have. Oh, we gotta go, we gotta get out of here. All right, thanks. If you have any questions, we'll talk in the hall. Thank you, Pete. Thank you, Patrick.